Here we'll look at a few examples of hypothesis tests, and I'm going to try to go as fast as I can through this, but still explain it thoroughly. So if you need to pause the video at any point, please do so. A battery manufacturer guarantees that the mean reserve capacity of a certain battery is greater than 1.5 hours. Okay, so stop a second. They're guaranteeing the mean reserve capacity, that's mu, mean, is greater than 1.5. So right away, there's claiming that mu is greater than 1.5. So you want to think about hypotheses and how that's going to show up. Okay, next sentence. To test this claim, you randomly select 45 batteries, okay, so N is 45, and find the mean reserve capacity to be 1.55 hours. Okay, so you selected a sample of 45 and find the mean to be 1.55. So that sample resulted in a mean of 1.55. So that is X bar. And this is where you have to get good at reading these questions and understand that we're looking at a population mean, and then we're going to use a sample mean to test that hypothesis about the population mean. So there's two means involved, the population and the sample. So you need to be able to read that question. And when they say you selected 45 batteries and the mean reserve was 1.55, that implies it comes from the sample. Okay, so it had been previously determined that the population standard deviation is 0.32. Okay, so probably unrealistically, we know that sigma, the population standard deviation, is 0.32. If alpha is 0.1, is there enough evidence to support the claim? Okay, so we need to recognize this is a hypothesis test because we're looking at supporting a claim. All right, so the first step is to write your hypotheses. Okay, so they are claiming that the mean reserve capacity was greater than 1.5 hours. So right away, mu is greater than 1.5, that's your alternative because of the greater than, which makes the null hypothesis mu equals 1.5. Okay, so the claim was the alternative. Okay, we know that alpha is 0.10. So the next step, after you write your hypotheses, is to create your rejection region for HO. And remember, that has to do with alpha. Okay, so mu greater than 1.5 means we're shading to the right with an area of 0.10 to its right. So that means we have 0.10 area to the right. Okay, so to create the rejection region, we do the inverse norm of 0.9 and we get 1.28. Okay, and we're using 0.9 there because that's if you have 10% to the right, there's 90% to the left. Okay, so our z-score that we're looking at there is 1.28. Okay, now, as far as the sampling distribution goes, X bar, we think that we're assuming that the mean is 1.5, that that's right in the center. That's our assumption. Now we need to test that assumption by taking a sample, which we did. And in that sample, we got a mean of 1.55. They tell us the sigma is 0.32. And we selected 45 batteries. Okay, so you find your test statistic, which is z equals x bar minus mu over sigma sub x bar. Okay, and this goes back to the SDSM chapter, so you have to be good at that. Okay, because everything was built off of that, which I mentioned at the time. Okay, so you take x bar, our sample mean was 1.55, minus our population assumed mean of 1.5, divided by sigma over the square root of n, and you end up with 1.05. Okay, so the z-score we end up with, 1.05, that's our test statistic, which is right about here. Okay, so x bar of 1.55. Okay, notice that that is not in our rejection region. So our decision is to fail to reject HO. And if we fail to reject HO, we're saying that HO is okay. which means we cannot support the claim, the alternative. Okay, so we fail to reject HO. There's not enough evidence to support the claim that the mean reserve capacity is greater than 1.5. Okay, I'll go through the next one faster. Okay, so I want you to read that, set up your hypotheses, and form the rejection region. Okay, and then I'll take it from there. Okay, so pause the video if you need to and work on this. Okay, so here's your hypotheses. They're saying they will reduce the cholesterol levels by more than 34 points, so they're trying to say that the mean is greater than 34. And there's 1% to the right because alpha is 0.01, which gives you a z-star value of 2.33. Okay, so then you find your test statistic. So you take the sample of 100 people, you get a sample mean of 37, and you know that sigma is 11.6. So when you do your x bar minus mu over sigma sub x bar, you end up with 2.586, or about 2.59. Okay, so 2.59, that is to the right of 2.33. So our sample mean of 37 ended up with a test statistic of 2.59, which is to the right of 2.33, which is in the rejection region. So our decision is to reject HO. And if we reject HO, so if HO is no good, so if HO's got to go, then the alternative is good, so we can support the claim. Okay, so there's enough evidence to support the claim that the mean decrease in cholesterol is more than 34 points. So mu greater than 34. Okay, and again, what this is telling us is if the population mean really was 34, like we assumed, to get a sample mean of 37 would be very unusual. And if that sample mean is too unusual, then it looks like our assumption was a bad assumption. That is the basic idea of what we just did. Okay, and then moving on to the last question. Okay, again, I'll ask you to read it and then pause the video and try it. I will show the hypotheses and then the rejection region, and then we'll go from there. Okay, so pause the video. Okay, so on this one, the bank is claiming that the mean wait time is 6 minutes, so mu equals 6. That's what they're claiming. So this one's a little bit different for a few reasons. One is the claim is the null hypothesis. And then the other reason is the opposite of 6 minutes is not equal to 6 minutes. Okay, so that will be the alternative hypotheses. Alpha is 0.05. So because it's a two-tailed test because of the not equals to, we're dividing that 0.05 into two areas, or two tails, to get 0.025. Okay, and the z-star values that go with those are negative 1.96 and positive 1.96. Okay, so we're assuming that the population mean right in the center there was 6. Now we need to collect the evidence and see if our sample results in a sample mean that is too far away from what we expected. Okay, so if we get a sample mean that is too far away from 6 minutes, then we're going to say that that was too unusual if 6 minutes was the actual population mean, that they wait 6 minutes. Okay, so we calculate the test statistic. Okay, we get 2.04, and 2.04 is just above, I hate it when that happens. I just tore my red pen apart. I hate it when I do that. I'll have to put this one in black here. Okay, 2.04, our test statistic is a little bit to the right of 1.96. And as long as it's to the right, it's in the rejection region. So what we're going to do here is reject HO, because getting that sample mean of 6.7 was more unusual than we were willing to go. Okay, so 6.7 was too far away from 6, from the center. So we're going to reject HO, and that means we're going to have enough evidence to reject the claim. So here, because the claim was HO, if we reject the claim, if we reject HO, we are rejecting the claim. Okay, so those are a few examples of hypothesis tests. So hopefully that makes more sense.